Hello, this is Dr. Cleveland again, and we're going to talk about some descriptive statistics for a data set. We're going to look at quartiles, ranges, histograms, and away we go. So what we've got here is in the column A, we've got the income of all the Wisconsin 50C3 public charities for the year 2015, and we're going to do some descriptive statistics. Now we're going to add a minimum, maximum, median, average, mode, standard deviation, and then we're going to use the data tool pack to add data. And there's a reason that I like to do this. First of all, to make sure you know how this works, and there's also real value in having a formula rather than just the table, and I'll show you how this works. So to get the minimum, I add the minimum min command, and then I'm going to go in A2 all the way down to the bottom here, and then I'm going to close my parentheses to give me a minimum value of $1. Now, so I don't have to scroll down each time, I'm going to just copy this, and as I put in my formulas, then I'm going to just copy the range. So max is for maximum, and then, oh well, I did something wrong here. So I'm going to copy this, Control C, and then I'm going to put that same value there. So I've got it all the way down, and then median is median. So clever, Excel, you do such a nice job. Average is average, or the mean. Okay, we got that. The mode, the most common number in the set. The data range is 0. And then we're going to take the standard deviation. And this is for the entire population. I'm going to do standard deviation of P. And then I'm going to just hit a backspace and copy so that I got the whole range. And what that standard deviation tells me is that the average distance from the average is over $2 million here, and the average distance from that for the data points is 30 million. So this is saying that the average distance goes way negative, which means that you have some very high outliers that are dragging that are affecting this data set. So that's just one quick way to interpret these descriptive statistics. Now, I'm going to use the analysis tool pack to do some data analysis, and I went to the data tab here, all the way over to data analysis. I want the descriptive statistics. So I hit OK, and my input range here at the top is going to be all of my numbers. Thank you very much. Then I'm going to hit return. Actually, I'm going to change this to A1 because I want my labels in the first row, so I know when the output comes out that it's labeled. Now, the default is to put a new worksheet in. I don't want to do that. I want my output range right here in this table. Whenever you're confronted with this little box here, you can click that to navigate on the page to say where you want it to go. I want it to go right there. And then make sure you click on Summary Statistics so you actually get some information. And then I'm going to click OK. And it's thinking, and oh look, it put together a nice table for us. And it's the income of the Wisconsin C3s here labeled at the top. And then it just gives you the numbers here, the mean, standard error, all these pieces of information about your data set. The count, the sum of, if you added up all the numbers, the maximum, the minimum, the range, the difference between the maximum and the minimum, and whether or not it's a skewed sample, and that says whether it's positive or negative skewed. This looks like it's positively skewed, and pretty substantially because that number is 30. And a low skew would be something around 2 or less. So these are descriptive statistics, and one reason that I like having the statistics where you actually have the formula is if you have a question, did I include all the data? These numbers here in the table that's automatically generated don't have the ranges that you use to do the statistics, and it's a personal choice, but I prefer to have, I just know where my data came from. So let's move on, and look at some quartiles, some percentiles, and then we're going to do a quick histogram. So quartiles look at the minimum, maximum, and then the 25th percentile, the 50th percentile, and 75th percentile. And for both the, quartile. So the quartiles are at 25%, 50%, and 75%. And what this means is they actually take an arithmetic mean, because if you did quartiles of, say, this range, it would give you a number that is not 1, 2, 3, or 4. It would give you something in between for the quartiles. And so it will add up, it will actually do some math to calculate a quartile, and the same thing is true for your percentiles, but it gives you an idea how distributed your data is. So for the quartile, the function is quartile, and what I want is inclusive, and I'm going to explain why I want inclusive in just a minute. So I can double click on that, and my array is once again this entire set of data, and then I'm going to absolute value that. So I hit F4 because I want that as I copy this equation down. I want the equation to follow. I want my data. And you see when this dialog box pulls up, you only have the opportunity to choose from the 25th, 50th, 75th percentile, the maximum, minimum values with the quartile command. So you're a little bit limited in what you can do with the quartile command. So then I put 0 in. That's going to give me my minimum. And look, it's $0. And then I'm going to grab the handle over here and copy this formula down. And you can see the minimum, the first quartile, the 25th percentile, the second quartile, the median are all of 0. And then when you get to 75th percent, 75%, you are actually starting to get into some positive numbers. Now, let's look at how you do a percentile. And here again, I'm going to do percentile inclusive, because that gives me all the numbers from the lowest number to the highest number. If you didn't do that, I'm going to show you what happens. You lose your minimum and maximum, and I'll show you that in the next column. So once again, you copy the whole range, and then you put the percentile, which is the percentage of within the data, and then I'm going to just have it over here. I like to include the information on this here. I like to have the numbers not hard-coded so I can change them. And then you copy your information down here, and just to underline that these are percentages, I'm going to change these decimals to percents. So you can see that these are percentiles. And look, even up to 60%. And one nice thing, I demonstrate why this is nice to have a number here that you can change. Say I went to 65th percentile. Oh, that actually gives me a positive number. 64 gives me 0. So I know somewhere between the 64th and 65th percentile, I get my first positive number. So more than 60% of your data here is 0. So that's going to tell you that the data must be skewed, because more than half of it is 0. Now I'm going to do the percentile exclusive here, because this will just give you an idea of what the difference is. And when you click on that, I want to delete that because I'm going to do F4 to absolute value that. So I have the absolute range, and then I'm going to put the percentile in, and look, I get an error message because the minimum is not included. The maximum is included, and you can see here that the numbers are not the same. They change slightly because you're eliminating the maximum and minimum. That's all we have for right now. Okay, so now what I'm going to do is I'm going to create a histogram with this data. And what I did is I created some bins, ranges or bins here, and this is the upper limit of the number. So anything up to $1. So all the zeros are going to fall into the 1 category. Anything up to $10,000 is up to, in this second range, 100,000, blah, 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 up to $1 billion. And I know that I'm going to have some values more than $1 billion because my maximum is 1.6 billion. So I just want to show you how this the software calculates this and depicts this. One reason I did these ranges with just basically powers of 10 is because it's not uncommon when you have a range of income or asset values, any sort of financial value over a large population, the values are not distributed equally among the population. And so taking the log of these numbers actually helps you. So this would be the log of log base 10. So this, if you took the log of this, you don't have to do this, but I'm just showing you what this means. The log of this number is 4. And if you copy this down, you'll see 4, 5, 6, 7, 8, 9. So when you would look at this data, you could actually, even though it's very skewed when you look at the raw data, if you took the log, it becomes a nice, concise set of data. But I'm going to delete that just because that's not the centerpiece of this discussion. What I'm going to do is I'm going to create now a histogram so you can understand how this is done, because you want to understand the distribution of the data. Usually the histograms are exactly the same ranges. So this would be like 10,000 to 20,000 to 30,000 to 40,000, 50,000 and up. But we don't have enough data to plug in there to make that work, which is why I use these power of 10. And my excuse for that is that I would translate these to logs, but I didn't want to do that for this video. So to get my histogram, I'm going to go back to the data tab. I'm going to go over to data analysis because I've plugged in my analysis toolkit. I've got, click down here on histogram, click OK, and now my input range is going to be, I'm going to click on this little box here. It's going to help me calculate get to any place on the worksheet for the range, and then I'm going to hit Shift, Control Shift and the down arrow to get the whole thing. Now I hit the return key, and it brings me back to my dialog box. Now I want my bin range. Oh, and I made a mistake here because once again, I want the titles in. So I'm going to do a 1. For my bin range, I want these values over here. Power of 10 values. I have included here my labels. And I always want to make sure that I have chart output so it gives me the graph. And I've got my output range, which is where it's going to be. Notice it's going to be on this spreadsheet, not a worksheet or new workbook. Click on the little box there, and I'm going to say I want my histogram values here. Hit return, and now I hit OK, and Excel will work its magic. And it gives me a nice histogram over here. Now what I'm going to do is I'm going to highlight these. I'm going to just click on Format Painter so I can get these as dollar values, because this will then, when I have my histogram, I'm going to make this bigger so that the values actually show up here underneath. And this $1 value is really the amount of data in that is actually skewing the data. So I'm just going to click on the little drag and drop boxes to remove that piece of data from the histogram so I don't see that. And one thing that this tells you is there's a fairly normal distribution. And you can even get rid of the series because that doesn't add any value. Now I wanted to highlight, remember that maximum was $1.6 billion. Our maximum range value was $1 billion. And so you have more than this $1 billion, and there's 5 data points that are more than $1 billion. So you have this very small data point out here. So that's how you do your histograms and your other descriptive statistics. I hope this helps.